What's going on, guys? Let's identify the intermolecular force within these molecules right here. So first of all, to find that, we have to draw the Lewis diagram, and then we have to determine in which condition, which of these three conditions it comes, right? So let's look at the SO2 first. So if I draw the Lewis diagram for SO2, how it's going to be look like? So S, we are going to have S right here, and single oxygen bond, and another double bond oxygen, and it's going to form an octet form, right? So we have six electrons right here, and two more, and here we're going to have 2, 4, 6, and here already 4, so 4 more. So if you look at this, this is not symmetric because these two electrons pull these atoms down, and that makes this one not symmetric. So if it's not symmetric and it doesn't have hydrogen bond is basically when hydrogen bond with fluorine, oxygen, or nitrogen. We don't have any of that condition, so no hydrogen, and since this is not symmetric, it's a polar. So polar and not symmetric, therefore this comes under dipole. So this is a dipole because not symmetric and polar, and also no hydrogen bonding, therefore this is a dipole, right? Dipole. So this is the first one. Let's look at the second one right here. So H2o molecule. So let's draw the Lewis diagram for this one. So here we are going to have oxygen in the middle and hydrogen right here. So we have 4 electrons and then 4 more electrons. 2, 4. Due to these 2 electrons, these electrons will pull these atoms down and make this one non-symmetric. So this is not symmetric. And if you look at this, even though this looks symmetric in this direction, and if you cut this way, this is not symmetric in this direction. So it should be symmetric in all the way, right? So that's the only way it should be. It could be symmetric. In this condition, it's not symmetric. Therefore, this is a polar. So this is a polar. And does it have hydrogen bonding? Hydrogen bonding is when hydrogen bond with fluorine, oxygen, or nitrogen. We have this situation right here. So we have hydrogen bonding. So polar and hydrogen bonding. Therefore, this is hydrogen bonding. Alright. So this is hydrogen bonding. So let's look at the third one right here. So third one, I write this right here. Third one we have SCO. Let's draw the Lewis diagram for that one. So S, we have double bond C, double bond O, and each of them are going to have 2 lone pair electrons. So here also lone pair electrons, and this is a linear shape, right? And it looks symmetric, but it's actually not symmetric because these atoms are not same. Like if we have oxygen, or sulfur, then it's symmetric. But here we have sulfur and oxygen right here. Therefore, this is not symmetric. So not symmetric. Therefore, this one is polar. And do we have a hydrogen bonding? Hydrogen bonding when hydrogen bond with fluorine, oxygen, nitrogen. We don't have any of that condition right here. Therefore, this is dipole. And let's look at the fourth one, CH2Cl2. So let's draw the Lewis diagram for that one, CH. So for the chlorine, it's going to be a little bit inclined, right, like this. And then this is going to be the shape of this molecule, and this one going to have, okay, it's going to be like this. And this one is, if you look at this is not symmetric, right? Not symmetric. Therefore, this is polar. And then do we have any hydrogen bonding? We don't have any of this hydrogen bonding. So this is a dipole-dipole. So let's grab the fifth one. Fifth one, we have carbon dioxide. So we have carbon dioxide, CO2. Let's draw the Lewis diagram. We are going to have a double bond O. Each of them have two lone pairs. And this one is symmetric because both of them are same atom and symmetric. Therefore, this is nonpolar. This is nonpolar. So whenever we have nonpolar, we have London dispersion forces. So this is London dispersion force, and that's how we identify the intermolecular forces. I hope you guys liked this video. See you next time.